How's everybody doing?
Very good.
There you go. Thanks for having me. So I'm guessing are all developers in the room? Any non-developers in the room?
No, non-developer.
Okay, no, I just like to know because like I asked some hand-raising questions, and so I like to kind of get an idea of what the percentages are. So I can just assume. So, how many of you in the room enjoy working with a project that you inherited from someone else? If you can rewrite it, okay, I've heard that. That's two of those, okay, but and then a maybe. All right.
Don't hate it, don't.
Okay, you don't hate it, don't love it. All right, that's fair. That's fair. So I'd like to talk a little bit about like why we typically don't like them. Like this is pretty typical. I've given this talk several times now. It's pretty typical to get that number of hands raised in a group this size, between 0 and 4. So I'd like to just spend a little bit of time talking about like why is it we don't like projects that we inherited from elsewhere. One of the biggest contributors, I think, is the terminology. We don't really have a lot of positive ways to talk about that kind of work. We have legacy code, which, despite that being an awesome book, I think so. But that title just makes it sound so negative. Like, why would you want to learn to work on something that's considered to be someone else's legacy? Like, it's not all that. It's really doesn't sound all that positive. Like I've never bumped into someone and they're like, yeah, I'm working on this awesome legacy project. Like it's just not something I hear. It's this idea of like legacy is something you should avoid. And even in Michael Feathers' definition of legacy code, if you read that, legacy code is untested code, the way he defines it. So pretty much his goal of the book is to get you to not write legacy code. So then almost reinforcing this negative connotation around the word. We also have like brownfield projects or dirtfield projects, or less pleasant names. There's rescue work. There's refactoring, which doesn't necessarily have a negative connotation, but it generally does for non-developers because they don't know what the hell that means. So getting a non-developer to understand what a refactoring project is usually a lot of work. So that's the terminology. I also think the pace of change in our industry makes it difficult to work on our older projects. There's always new frameworks coming out. There's always new languages coming out. There's always new versions of older platforms coming out. And if we're working on a project that lives on older versions than what's out and what's popular, then I feel like there's this fear that the next job will be that much harder to get. So like a project we're on now, we know everything we need to know. But what about the next project? When we have all the skills we need in order to land that job? I think that it's also just hard. Like you have to figure out what someone else was doing. You have to get inside of their head. You have to reverse engineer their mental model. It's quite a challenge to look at what someone has left behind and then try to, from that, reverse engineer what they were thinking, why they made choices they did, why they locked you into certain decisions, why they chose certain dependencies, why they chose certain design patterns. It's quite a challenge, and that I feel leads to this challenge and this frustration that they did it wrong. The person before you, and I feel like this leads to the desire to rewrite, is that they knew what they were doing. Like they didn't solve the problem adequately. They made it that much harder for you to come in and maintain it. They made it that much harder for you to fix bugs. If you could get rid of a dependency, it would be so much easier. If you could, get rid of a feature, it would be so much easier. There are all these aspects that because of what they did, your life is hard. So those are kind of like the top ones that I think of. Do you guys have any other reasons that I didn't touch on? For reasons why you guys don't like? Since none of you raised your hand, I'm assuming there's some dislike.
Legacy code often actually has users. And by that I mean, if it's a library, there's third parties or outside code that depends on it, and therefore it's ossified in a way that degrees to which you can change it or limit it because people are actually getting use out of it already.
Right. Okay, so the fact that it's being used add, create some limitation with
Yes.
decisions you can make, changes
The
you
flip
can make.
side of success is the responsibility for backward compatibility.
Gotcha. Okay. That's a good one.
Not always the architecture, but the lack of architecture, or the fact that legacy code's been around for a while, meaning it probably wasn't one person or one team who's touched it, but it's had several teams' idea of what the right way to proceed with this code is, or just shoehorning in as fast as they can and moving on throughout its life, not just one idea that you have to detangle.
Right, and they feel like there's multiple teams working on it, and that can be frustrating, and that can be exacerbated by the need to support the older way of doing things. So the team that came in may have made the decision, well, we'll deal with this older way, but we'll build everything else new, better, and so then you get this conflict of what's the right choice. So, any others?
I feel like sometimes like code just gets rushed, and like you're like, yeah, I understand why they did this, but it's like you're like feel sorry for the guy because he was probably like caught last minute and like
Right.
yeah, I don't know.
But it's still frustrating to deal with the result.
Yeah.
Right, so it's like, yeah, you can understand that that person is in a hurry, but you have to suffer the consequences.
It often has like non-intuitive side effects sometimes too, or behaviors where you look at a class or a function and it's named a certain way. You pretty much have in your head what it should do, and then you start to make decisions based on that, and you find out, all right, well, it does this, but it also does this, which doesn't even make sense, but okay, now I have to handle that as well.
Right, right. So lack of. So again, I think that's part of the mental model, maybe
Yeah,
even some of the
right.
documentation. So like the name conveys to you, that it should do something.
Yeah.
And then you find that it doesn't do that, or the documentation suggests that it works a certain way, and then you find that it doesn't
Or
work.
yeah,
that
or
way.
someone just threw in something that is completely like a completely separate piece of logic. They just threw it in there because it fit.
Right.
It's fast but it doesn't fit with the code. You think about logic. That's there. You can't handle it.
But I think also, I feel I'm a database administrator for the past 20 years, and looking at code and PLSQL code and things that developers create, you often feel that they are not looking at the underlying technologies. I go in there and I try to create referential integrity, and they supposedly handle it within the code because when I try to put it in, it breaks the software. But yet, all the data is where it's supposed to be, so they've done something really strange within the code that doesn't let me put in referential integrity. So you don't understand the underlying technology, the benefits of it.
Gotcha.
Going off of some of the things that just recently been said, fragility.
Fragility, okay.
You try to make a seemingly simple change, and all of a sudden everything's broken for no apparent reason.
Yeah, the seemingly simple changes I've found are really easy to describe to your boss. Like, your boss will come to you and say, make it do this. I'm like, oh, that sounds so simple. Of course I'll make it do that. And then he comes by a week later, and you're not done because of that fragility problem. And that now you're the one who feels like you have no pressure to get something done quickly, and that's always frustrating. So I think like every reason I've heard here, I think those are all really fair, really valid. I feel like I cope with those all the time, and yet I still love it. So I'd like to talk a little bit about why. So let's go backwards a little bit. Early in my career, I had a chance to work on this aircraft. This is the X-31 experimental fighter. So it's an X-plane for the non-aerospace buffs in the room. X-planes are experimental aircraft that have been built to test out a specific design or technology, or to try to answer a question, whether or not something was capable. For example, X-1 broke the sound barrier, and there have been a long succession of X-planes that have done really cool things since. This aircraft was built to test the feasibility of thrust vectoring. So it has these little panels back here, and that controls most of what makes the plane point in a particular direction. It's not the wings so much, they help, but the bulk of it is all right here. So basically pointing the thrust in a particular direction to make the airplane go. Had some really cool flight characteristics, able to maintain a level flight at a 70-degree pitch. so it could fly kind of like that, and kind of turn more like a helicopter. In the 80s, they did a lot of simulated dogfights with U.S. military aircraft, and it was able to keep its nose pointed at the other aircraft for about 80% of the dogfight. So if it had guns, that's where the bullets would have been going. So really, really awesome, awesomely maneuverable aircraft. Was built with the state-of-the-art technology that was available in 1985. And that's an important little detail that I'm going to come back to several times. You'll probably be sick of hearing it. So this aircraft had, it was proving when it was first built, it was built to kind of see, like, could thrust vectoring be used to get superiority and maneuverability in a dogfight, essentially? Could an aircraft be super maneuverable in one-on-one with another aircraft? And it kind of proved that out, and then they kind of set it to the side for several years. And then in the late 90s, they decided to bring it back to life and answer some other questions with it. Specifically, they wanted to see if the bottom of the aircraft could be used as a brake to require, so that the airplane would need less distance to land. So by using wind resistance on the bottom of the aircraft, could you get it to be able to land in a super short distance, like say on an aircraft carrier, without needing a hook? Aircraft that land on aircraft carriers use a hook and catch system. It's actually really puts a huge strain on the aircraft because you have an aircraft going super fast and then it jerks to a stop all of a sudden. And so there's only so many times that you can do that with an aircraft before it has to be decommissioned. So that makes it rather expensive. So that's what it was one of the primary things they were testing with this. And that was the phase of the project that I worked on, was that after they woke it back up in the late 90s, after being built in the mid 80s. So we had lots of software was involved in this aircraft. There was lots of testing software in particular, and that's the part that I worked on, was the testing software. It was an application that was used to do formal verification and validation of the software that actually ran on the aircraft. So it was used to determine whether or not the aircraft was safe for a human to get behind. And again, state-of-the-art 1985, this ran on a 286 with 16 megahertz of RAM. 16 megahertz processor and 4 megs of RAM. Anything more capable than that, it would crash. Gave it a faster processor, it would crash. Gave it more RAM, it would crash. Gave it something more modern than a 286, it would crash. Because the timing of the test software was very, very particular to the clock cycle and the amount of memory that was available because of the way it had been built. So the Navy had a problem in 1999, early 2000, to keep 286s alive in order to determine whether this was safe to fly. So the team I was on, we were tasked with seeing if we could replace that app and still be able to run the test suite, and still be able to talk to the airplane, and still be able to talk to the other components of that application we talked to see if we could still perform that function but do it with more modern hardware and be able to not need a 286 to get the job done. At the time, it was like Pentium class processor that you could get from your local computer store. We targeted Windows 2000 was the operating system we targeted. We wrote our replacement in Delphi. The original was written in Modulo 2. We had quite a few challenges. We had source code for the original app. We had no confidence that the source code we had was for the compiled binary that was verified for use. So we couldn't really trust it. And we did find some slight discrepancies between what it did and between what we were able to read in the code and what the compiled binary did. And even if that was the right source code, we didn't have the build environment, so we couldn't have built it anyway. We didn't have the dependencies. We didn't have we didn't have a compiler for the toolkit. So like we had source code, we had nothing else we needed to actually do anything useful with it. We were successful. We did manage to replace it. and still perform the function. And we were actually able to perform it faster, which was a nice benefit. So that project really gave me this taste of what it was like to work with like a behavioral-driven functional testing tool, because that's what we were writing. It was basically Cucumber for an aircraft, or Jasmine for an aircraft. But what we were asked to do was to completely replace the engine that ran those tests. We were asked to take like this block in the block diagram of a larger system and replace it without being able to change anything about the other components. So real similar to the issue that you mentioned, where it's used. So there were systems upstream and systems downstream that we couldn't change. So yeah, I found this to be an incredibly fascinating, incredibly rewarding project. And it really started to influence my choices in my career later down the line. Like I started to value testing more and more. I started to value trying to reuse older components more and more. And I noticed that my contemporaries resisted some of these things. First, testing was resisted. Testing's not as resisted anymore. But reusing older code is still very resisted. And the more and more I thought about this problem, I tried to like why do I like this and other people don't? I started to look outside the software world to see if there's anything outside of software that might be a good metaphor for changing the terminology or changing the context that we use to look at our work. And I kind of settled in on construction. Construction is the best metaphor for building a new app. I feel like it starts to work out, but then it starts to fall apart. Construction's not as malleable as software. Construction projects usually have these really big grand plans at the beginning. We tend to not like really big grand plans at the beginning. But I feel like with an existing project, it's a really good metaphor. If you've ever had a partner who's asked you to like remodel a kitchen or express frustration about remodeling a kitchen, then you've had to take this space and replace it without affecting the other components of the system. If you look at the house or the floor plan as a system, as a block diagram, we go back and we imagine that this is the kitchen, and that's the dining room, and then that's the living room. And it's a very similar relationship, and yet this is something that is incredibly popular to do. Not only that, but there are lots of really positive ways to talk about it. There's remodeling, there's restoring, there's revitalizing, there's a whole host of television shows devoted to the art of taking taking an older house that might have been built in the 1920s and making it beautiful. The one that I found most inspiring was This Old House, which is where I got the name of the talk from. It's kind of a spin-off of that, where if you've never seen it, it's these craftsmen who really go into an existing space and they look at the beauty that's there. And it might be beauty that's been covered up, it might be beauty that has not survived very well over time, and they bring that beauty back to life. And while doing so, they make the house better. So they make it a better house than it was before. It's serving the owners better than it used to. If they're remodeling a kitchen, they're not doing antique restoration of the kitchen. You're getting the modern appliances. It's a modern kitchen, but it has but they still preserve some of the older aesthetics and the older architectural components that are part of the house. And they seem to do a really good job of taking that into account. And they fix problems along the way. So they'll be down in the basement and they'll show like cracks in the foundation that they have to fix, or a floor that's crooked that they have to fix, or they'll start to remodel a room and they'll find rotting beams that they have to replace. And I feel like there are analogs to that in the software world that we deal with whenever we're dealing with an older project. And I feel like those are the things that actually make it frustrating, and those are the things that make the projects last longer. Because when we think about just going in there and working on the code, we have this very simple thing in mind. We're making the kitchen better. But in order to make the kitchen better, we have to take the appliances out, and then we notice termite damage. Well, crap! Now we have a new problem. Now we have to fix termite damage, and the clients might not have budget to remodel the kitchen and fix the termite damage. So now they've got a hard decision. They're likely fixing the termite damage for them and then putting their appliances back. And I feel like that's a very similar scenario like that happens all the time in software projects. You know, you'll discover that the architecture just does not support what the client wants to do with it. It's not that it's not possible. It's not possible within the budget or the constraints that they split up. Whether this be time, whether this be the tools that they want to use. You know, it's quite a challenge. So I'd like to talk about like other ways that this kind of metaphors kind of helps me think about, you know, that kind of work differently. I think it can be helpful to think about software in terms of archaeology. So when we, you know, what we're looking at is what the predecessors left behind, and from that we're trying to learn more about them. Trying to learn. So like in the archaeology context, you have smashed bits of pottery and you try to learn what they did from their list. So in the software world, like we have code, and try to from that code try to imagine what that person's skill level was, how time constrained were they, how much experience they had when they were starting with it, how much, you know, what was their work environment like? You know, did they have other people they could ask questions? Were they working all by themselves? Were they working on a small team? Were they working on a ginormous team? Was it a process-heavy project? Was it a process-light project? You know, those can all really influence the way the actual finished product, the finished code turns out. And those all have an effect. And I think, you know, when we're studying an existing project, if we give some consideration to those aspects, I think it can be really helpful. I think it can help with some of the frustration. I feel like you kind of hinted at it when you said that you try to take into account that the person might have not had a whole lot of time, but it's still frustrating when you're dealing with the product of a rush job. But it's the best that they can do that day, right? And so I think like instead of getting mad at, you know, the person who worked on it, like maybe, you know, show them a little bit of empathy, and it's like that's the best that person could do that day. And yeah, you've got to deal with it. Yeah, it sucks. But they didn't show up to their job site intentionally saying they're going to screw up the project today. Like they, you know, has anybody here ever done that? I've never done that. Like, you know, everyone's always ever done their best. And I feel like it's even more heartening to realize, like, I feel like that point gets driven home when you're consuming a project that you wrote. So I had the opportunity to do this. I had worked for a company and then left and then come back, and was fixing a bug. I was like, oh, what idiot wrote this? And so use the equivalent of blame, like get blame to see who wrote the offending commit. And it was me. Like, yeah, I made that horrible decision. I mean, and I've heard lots of stories of other people who've done that, where it's like, you know, what idiot wrote that? Oh, that idiot was me. Like, I was that idiot. So I think, like, you know, having a little bit of heart, having a little bit of empathy, and really kind of, you know, taking into consideration that people do their best work can help a lot. I think the pace of change is a really fair problem. And I feel like the solution I have for that can also be derived from the context of remodeling project. So if you have a house that was built in the 1890s and you're remodeling it, where do you go to get your tools? Anyone have an older house that they've ever remodeled or had a friend?
You still go to the same hardware store.
Right. So when you go there, they don't have an 1890s section, right? And they don't have 1890s nails, they don't have 1890s hammers, they don't have 1890s drills. You buy the latest and greatest of those materials that are available. You don't get lumber that was around in the 1890s. You know, you don't build the code that was available in the 1890s. Like, you usually update these things to be modern. But yet, I find when I inherit an older project, there's kind of this assumption by everyone who is expected to touch it that they'll continue to use those ancient tools. So even though the project was originally written in, like, say, 2000, there's this expectation that, you know, the IDE that we'll use is the one that was available in 2000. You know, we won't even try to use a modern build environment, or we won't, you know, if you've ever inherited like a VB6 project, the Visual Basic 6 IDE was dreadfully used. Like, you know, one of the first things I would try to do is try to, you know, use that to build, but not use it to edit, right? Because it's a very frustrating editor. So you just don't go there. So I think like that's where we can get back some of the I feel like that's where we can get back some of the benefits of kind of staying modern in our industry, is trying to find ways to make new tools work with older code. So examples of tools can be testing tools. So like upgrading your XUnit suite or adding one if there's one's not there. Upgrading other dependencies that are relatively safe. Upgrading the build environment. Those are usually relatively low risk things to improve, and usually reap a lot of benefits in terms of productivity. The bit about it being tough, I think, is actually that's the one that I think again we can look towards remodeling. I feel like it's a good thing. It's actually, so yeah, it's hard, and that's good. It's good that it's hard. That's what we're hired to do, to solve hard problems. We're not hired to solve easy problems. Otherwise, this job wouldn't be interesting. And if you look at the landscape of companies who do new construction and companies who do remodeling work, it's a pretty nice mix. And the streets, especially like walking around down here, are dotted with like really nicely maintained older homes. It's not that somebody decides to move to Pittsburgh and they bulldoze the house that's there and builds a new one. And if everyone who moved to Pittsburgh did that, the city would look very, very different. And yet that's what we do all the time whenever we're tasked with software for. Is just, oh, well, the developer before me was an idiot. I'll just wipe out everything they did and build from scratch. So, and I think in there is a little bit of recession proofing as well. I feel like maintaining old stuff will always need to be done. Maintaining successful things will always need to be done. A nice feature of a legacy app is it has users. It has people who are willing to pay for it. It's providing enough value that somebody wants to keep it working and wants it to work better, and they're able to pay you to make it do those things. So I feel like as long as the app that you're working on is providing value to somebody, then that value can trickle down to you and can help you weather financial storms that if you're only focused on new apps and riding the latest startup wave, then that can be a much larger challenge. I feel like the startup community is going to feel the pain of recession much sooner than other segments of the industry. So that's kind of like to kind of bring this to a close and just kind of see, like, nobody raised your hand earlier. Did I change anybody's mind at all? I got some maybes. Okay, that's good. That's good.
I don't know.
Still a maybe. Okay, that's cool. That's cool. So if you're interested, but would like to try it on your own and try to find some safe ways to try it on your own, I've got some ideas for things you could go do relatively quickly. One is to go work on an open source project. I feel like every open source project, unless you're the one who created it on GitHub or wherever you're consuming it from, is a legacy project. So if you enjoy working in that context, then try to analyze why you don't enjoy doing the same work when you get paid for it. What is it that makes it different? I also think it's a great way to kind of get to learn like what help projects like that need the most. I feel like issue triage is a great way to jump in and help a project. That can be a great way to help a project that you're inheriting from someone else as well, is to hit the issue tracker and then figure out what can you close out, what's actually already been fixed, what's no longer an issue. I think you can work on integrating new tools into your current workflows. If you're working on a project now and it's frustrating, try to look at ways that you can take more modern tools and bring them into your workflow, and then write about having done so, and share that knowledge with others who may be in a similar situation. I also think it can be helpful to practice working under constraints. It's not something we generally do a lot. There's a great set of cards that's more focused for web developers called Constraint Step that you can get. It's by Stephen Mill. And it was a Kickstarter project, and I think you can still buy them. But the ideas are these cards that you flip out in front of you, and they place constraints on the activity you're about to perform. So one of them is like no CSS, or everything has to be keyboard navigatable. So like the user can't use a mouse. So for like whatever you're working on for the next like hour, you place this constraint on yourself. And I feel like those by placing constraints on ourselves, that's where we can really learn to have more creative flexibility. And I feel like that can help prep us for what it's going to be like when we do inherit somebody else's code that has a whole bunch of constraints that we can't just decide to stop following anymore. So I feel like it's a very safe environment to kind of just get used to having an arm tied behind your back. So yeah, so I'd like to open it up for questions and yeah, so.